Okay, in this video, what we're going to do is we're going to go over something called a cognitive study guide. And a cognitive study guide is a study guide where I show you how you think your way through something. And then I'll do separate video. I don't know if it's going to be one video or more than one video, going through the actual individual rules. So some of you have all the rules in your head, but you're just not sure when to apply them. So what I would do is do a practice guide. Notice that there's a whole folder here called naming practice. There's ionic naming, there's mixed naming, there's quizzes where you could quiz yourself and then the answers are given to you. So you're definitely going to want to make sure that you go through some of these to see if you're naming them accurately before you start figuring out what kinds of stuff do you need help with. If you're completely lost at this point, you're not keeping up with the work, and there is nothing I can do to fix that except tell you that you need to put in your half an hour a day of chemistry time. You were warned at the beginning of the year how much this requires, and unfortunately, there's kind of no way around it. This is how it's done. So the best thing to do is to also, one of the things you could do if you were really in a panicked situation is do one of the things I recommended right from the beginning. Use your phone. It is one of the best tools that you have. Go into your whatever you use to buy apps and buy apps or get free apps to learn your elements. And there are definitely going to be apps or Quizlet flashcards for naming chemical compounds. The only difference is going to be that I don't have any control when you use those resources, which compounds you're going to get. Whereas using the practice that's in the drive, that's the baseline kind of for the compounds I expect you to be able to do. So you definitely want to look at them at least so that you know you're trying to practice the right ones. So if at this point you're kind of in a panic mode, also don't worry. In the grand scheme of things, your notes are worth 5 times what this quiz is worth. And you have an exam, but your exam is not until you get back from Thanksgiving break. And that exam is only on this material. It's only on naming. It's only on chemical bonding, the beginnings of chemical bonding, and your periodic table. So the more you practice this, the more you sit down and actually get it done, the better this quarter is going to go. So I'm going to grab, I'm actually going to go to the work plan to get this because I'm not exactly sure where I have it filed. So when you go to the work plan, you'll notice that I have a document tied to the work plan called Cognitive Walkthrough. So here it is. It says November 26th. Here's the YouTube playlist with all the videos that have to do with naming, including the ones that you guys did in class when I was absent, as well as a new video of me going over the ionic naming slideshow and everything else that I managed to get done today and upload for you. So even if you miss it for the quiz, there's still time to do it in time for the test. So this is something where it's never too late for you to learn this in chemistry because it will always apply, right? From now on, we're doing nothing but chemical reactions. So you have to be able to name chemical compounds and write formulas, or you're just going to be dead in the water. So you kind of have no choice. At this point, your back is to the wall. You have to learn this. So there's kind of not going to be any making excuses after a while. You just have to sit yourself down and get it down. Um, all right. So this table is something that I ask kids to walk yourself through this, and it mirrors the table that's on one of the study guides. So let me pull up which study guide that is. Okay, you've got elements and compounds, notes in the study guides. There is a study guide that's like a super, super summarized version. It's just one page back and front. Okay, and on the first page, it gives you like a super summarized version of all the rules. So if you're looking for a place to put it all in one place where it's less stuff for you to look at, this is the study guide you want to use. Okay, so here's the first half of the page, talks about molecular naming. The second half of the page does ionic naming. And then there's steps at the top here. And this is the steps I've been walking you through the whole thing. right? Look at the elements and count the elements. That's not hard. One, can you tell if there's a metal there? Two, can you tell if it's binary? Does it have two elements or more than two elements? Okay. Then you're going to go out from there and start making decisions. So if you look at the way I have this table set up, we're going to do the blank one, but this is one that's done for you already. And I have it set up kind of, I had to really stop myself because I've been doing this for many, many years. I first learned how to do chemical naming in 2002, 2001. So it's a long time ago now. Um, but still, I didn't learn it when I was a teenager. I don't remember if it was even taught to me. I know that chemistry did not go that well when I was in high school. So I know that it's a difficult course. I'm not denying that. Um, these are the steps I am going through in my own head. I'm just doing it faster than you. And that's because I have those neural pathways in place because I've practiced a lot. Okay, so you're not going to get better by not practicing. You have to practice this a lot so that you can get really good at it. So the first thing I always do is I look for a metal. Sometimes I run into a compound where I don't see a metal right away, and I have to kind of do a double take. So in this one, right, I don't see a metal right away. So I might first be like, oh, that's covalent. And then I have to go back and do a double take. Hold on. Nitrogen, hydrogen, chlorine, that has three elements. That's not binary. I'm either going to need to rely on the ones that I have on my table E, which you will get table E eventually, just not for the six most common polyatomics. In this case, this is ammonium. It's a polyatomic that you've memorized. So you should actually see it right away. It should pop right out at you because you have it memorized. So because it's not binary, you're going to be like, oh, I see a polyatomic ion. I'm going to name this using polyatomic ions and the other rules that I know. So for each one of these, basically that's what this does on the summary is it walks you through why did I do what I did at each step. Okay, so I have an initial identification. Oh, this is two elements. It's first of all, I don't see any metals. Second of all, it's definitely binary. This is covalent or molecular. I'm going to use Greek prefixes and name it using molecular naming rules. Okay, so there's like a really orderly way that I'm going through this process. At some point, though, you'll memorize it so well, you kind of won't realize you're doing the steps. But I know that you guys are not necessarily at that level yet. So when we're going to do this outline, we're going to do that exact same thing. You should get your periodic table and walk yourself through it with me. Okay? Go get your periodic table, make sure it's in front of you. Okay, so we're going to do this in both directions. In one direction, we have to go from a formula to a name, and in the other direction, we have to go from a name to a formula. And so there's a few different ones here. I'm going to do them in order, although on a quiz or test, particularly if you're having trouble with this and you're still keeping things in very separate categories, I might recommend that you go through and first identify everything and then decide which ones you want to do first. Do you want to do all the molecular ones so that you don't accidentally put Greek prefixes on ionic compounds? Um, that kind of stuff. Okay, so first thing I'm going to do is I'm going to check this to see if it's binary. Potassium, bromine, that's two elements, so yes. Yes, it's binary. Sorry, it didn't have me signed in as me, so it wouldn't let me type. Okay, now, is it ionic or molecular? The second question always is going to tell me if it's binary, I can make this decision strictly on whether or not there's a metal present. Okay, so there is a metal. Potassium is in group 1 on the periodic table all the way on the left, so that makes that a metal. That's an alkali metal. So yes, so this is ionic. So do I need to adjust my identification based off of what I figured out? No, right? If at first I check to see if it's polyatomic and I don't see any polyatomics, I don't usually need to adjust my identification. So I'm good. Okay, now how do I apply the correct rules and name it? This is a binary ionic compound. So if it doesn't have any metals that have multiple charges, those are going to be your transition metals, and it doesn't have any polyatomics, it's actually very simple. I just name the metal and then I name the nonmetal. But when I name the nonmetal, I change the ending to IDE, which you're going to find is something we do in all the compounds. Okay. So this is just potassium. And I do need to know how to spell it so I can write the name. And then this is bromine. I'm going to go ahead and take this ending off and make it bromide. And I'm done. Pretty easy. Okay, next one. First thing I'm going to do is check to see if it's binary. I see 1 nitrogen, 2 hydrogen, 3 chlorine. No, it's not binary. I'm going to classify it as ionic or molecular. Now, if you're forgetting that it cannot be molecular if it has more than 2 elements, you might say here, oh, it's molecular. The problem is that it's not molecular. It has a polyatomic ion in it. And so that makes it an ionic compound. Okay, so that's why it's really important that you know these on site. Yes, you're going to have table E. How will you know to check table E? Table E has 30 things on it. You need some clues built into your understanding of how to name compounds that are going to help you figure out when to go to table E and what you're looking for, right? So just having a reference table doesn't make you bulletproof. If you don't know how to use your reference tables or when to check them, they're useless to you. So this is why memorization is better than using a reference table all the time. But there's lots of stuff you're going to need a reference table for. No one expects you to memorize the atomic numbers or the atomic masses of elements. No one expects you to memorize their electronegativities or, well, there's a lot of other stuff on there that you need to worry about. All right, so I'm not going to adjust my identification because I picked up on the fact that this is polyatomic right away. I'm going to go ahead and just name the polyatomic. I memorized it. It's ammonium. And chloride. All right, let's get down to the next one. This one is nickel plus nitrogen and then oxygen. So this is definitely not binary. It does contain a transition metal, nickel, so it is ionic. And I'm going to add to my adjustment, not that I am changing it from ionic to molecular, but I'm going to add that I noticed something besides the polyatomic. I should probably just start identifying the polyatomics in this column. This is ammonium. This is nitrate. That polyatomic is a nitrate. Okay, now when I'm doing this identification, I'm going to have to point out to myself that nickel is a transition metal. The fact that it's a transition metal, it's in between groups 3 and 12. That means that this is going to require Roman numerals, which means I'm going to have to backwards engineer the charges to figure out what charge is on this nickel. Okay, so if you were using a periodic table with charges on it, that still doesn't really help you. And the reason why it doesn't really help you is because it isn't going to give you information about which of the 2 charges you're supposed to be using. You're going to have to figure out which charge you're using based off of what's happening with your polyatomic and the balancing of the charges. Okay, so since there are nitrate has a -1 charge, okay, and there are 2 of them, you're going to know that this is going to add up to a -2. So if this is a compound, it's already in the formula, it's already balanced, then this has to be a +2 to balance it out. So when I write the name, I'm going to name nickel, Roman numeral 2, nitrate, okay? I'm just going to type this up at the top. I'll put the link to this video attached to this sheet when I'm done. Somebody's actually on right now. Whoever Anonymous Kraken is. That's adorable. Is probably wondering why I'm actively typing answers in because I'm making a video, Anonymous Kraken. Okay, let's look at the next one. Now I've got to deal with this word thing. Okay, when it's in words, it's going to get a little bit trickier to spot, particularly polyatomics, especially polyatomics you're not familiar with. So the 6 that I gave you to memorize, I gave you those because those are the ones I want you to recognize on site. And then anything else that sticks out at you usually will have an ending that is not IDE. That is not IDE. It'll be ATE, IUM. There's like actually, unfortunately, 2 other ones that have IDE endings. And so we'll kind of practice with those as we get to them. So this one has an IDE ending. It does have only two elements. This represents sodium, and since this has an IDE ending, it is not the polyatomic. It is just phosphorus. So this is indeed binary, yes. Okay. Sodium is a group 1 metal. So if it's binary and it has a metal in it, I'm going to say it's flat out ionic. Okay, and I don't really have anything to note here except I'm going to write you a note. Don't confuse it with phosphate. Okay, phosphate has a different ending. That's how you know it's a polyatomic. I do have to balance this, though, to get the formula right because it is ionic. So sodium has a +1 charge. Phosphorus would typically have a -3 charge because it's in group 15. So I'm going to end up with Na3. Oop, I have to learn to stop hitting the wrong thing at the wrong time. Sorry, you guys. P. I have to turn off my, there we go. So Na3P. All right. Dinitrogen tetroxide. Oh, alarm bells just went off for me. First of all, the elements here are nitrogen and oxygen. So there's only two elements, nitrogen and oxygen, only two types. So yes, this is still binary. And because it's got Greek prefixes, I'm going to go straight to this is molecular. Okay, remember if it has Greek prefixes, it's automatically molecular because you can't use Greek prefixes on ionic compounds. You're not allowed. Okay, someday one of you is going to actually become some kind of crazy chemist and come back to me and be like, well, actually, yes, there is some well actuallys. That is way beyond the scope of what we're doing in this little high school general chemistry class, so don't get crazy. Okay, dinitrogen tetroxide is definitely molecular. I'm just going to do what the Greek prefixes tell me to do. The Greek prefix tells me to put dinitrogen, 2 nitrogen. So I'm going to do 2 nitrogen. Then it tells me I need tetroxide. Tetroxide is 4 oxygen. So I'm going to do 4 oxygen. And that's all I have to do. I just do what the Greek prefixes tell me to do. Okay, that's what they pay me for. Okay, sodium sulfate. Ah, see that ending? Ding, 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 ding. That ending tells me there's a polyatomic there. Now, not all of them end in ATE, but a lot of them do. And so that usually helps us a lot. So that is not binary. Okay. Not only does it have a metal, it has a polyatomic. So we're definitely in ionic territory here. But we lucked out. We got a nice simple metal. Sodium is a nice simple metal. It's a group 1 metal. It has a +1 charge. Okay. Sulfate is the polyatomic of choice here, and polyatomic sulfate has -2 charge. So sodium is in group 1, it has a +1, sulfate has a -2 charge, and so that means that it's going to be Na2SO4. Okay, now again, there is no decision making on my part about the formula for this. Okay, the 2 I have to make a decision about on the sodium because I'm balancing charges to write this formula. But sulfate comes as a package deal. Polyatomics just come that way. So there's no dispute about that. All right, ammonium oxide. Ammonium is a polyatomic. I memorized it, so I will definitely know that it is there. Okay, so ammonium, is it binary? No, it's not binary. Okay, this has a polyatomic in it. The fact that it has a polyatomic in it automatically makes it ionic. Okay, so ammonium really can't be confused with anything else. We'll get to some other issues later where we might confuse it with something else, but it's not. It doesn't. There's no element on the periodic table really that I guess somebody could pull a americium off the bottom of the table, but I don't think I'm even giving you one with that on it. So ammonium is NH4. Now there's some charge balancing here because this is ionic. Ammonium has a +1 charge. And oxygen has a -2 because everybody in group 16, unless we're running into some exceptions, is going to have a -2 charge. So that means I actually need 2 ammonium to balance this out. So I'm going to do the same thing I would do if the polyatomic was at the end. If I say I need two of these, I have a problem where it looks like I have 42 hydrogen. So I'm going to go ahead and put a parentheses around this ammonium to make sure everybody knows that what I mean to say is that I have two ammonium, not that I have 42 hydrogen. Some of you might think 42 hydrogen is not possible, but it depends on the compound. All right, so there's your formula for ammonium oxide. Iron 3 oxide. This is indeed binary. It just has iron and oxygen. Iron is most definitely a metal. So this is an ionic compound. In fact, it's actually just an ionic binary compound. But watch out, iron is a transition metal. And I was basically, when I have a name, when I'm giving it to written out, since it has Roman numerals on it, that ding, ding, ding tells me that has additional charges. But the charge is given to me here. So I have an iron with a +3 and an oxygen with a -2. The charge bouncing, let's just do that in a different video. I actually did this in the slideshow and I did it in the ionic slideshow video. So we can get into that charge bouncing another time. When you have two different charges that don't balance easily, you're going to bring them to a common multiple. And so since iron has a +3 and oxygen has a -2, you're going to bring them both to 6. So it would take me 2 iron, and it would take me 3 oxygen to get those charges to both add up to 6. And N2O5, oof, it's molecular, thank goodness. Okay, so it is binary. It is molecular because it doesn't contain any metals. So I have to look at my periodic table. I don't have to look at my periodic table anymore. I know where nitrogen and oxygen live. This is kind of what your goal is the less you have to check. You should really only have to check for the ones you don't use a lot. And that's going to speed up your work and make you feel more confident. Okay, now we're back in molecular land, so I'm allowed to use Greek prefixes. So I'm going to go ahead and say dinitrogen pentoxide. Okay, and last but not least, let's go in the other direction. When you're dealing with a formula and you need to write out a formula, a name, you do have to be on the lookout. Okay, so yes, this is binary. It has a metal. Iron is a metal. So yes, this is ionic. Ding, ding, ding. Iron is a transition metal. Okay, so I have to backwards engineer the charge on this. Now, it just so happens that this is the exact same compound, Fe2O3, written in the other direction. So I would have to be responsible if I was writing it in this direction for doing iron 3. Okay, that was just me modeling how you work your way through this. Check out some of the other videos if you need more help on charge balancing or telling if a compound is molecular or not.